Hello everyone, welcome back. Today we're talking about lateral movement via overpass the hash. This is a little bit different from pass the hash, but it has a lot of overlap. I want you to imagine the scenario to be something like this. Let's say you have access to a local administrator account. Maybe it's just a local user specific to their device, but you can't really use this account to pivot anywhere interesting. Now, if you can get someone with higher privileges to log in, let's say cause a little bit of trouble and maybe get the local IT admin to log in, you can use those stored credentials on Windows to pivot to that account on different devices, even without knowing what the password is. Now, what's the difference between pass the hash and overpass the hash? It turns out it's really just differing authentication methods. Pass the hash is fairly straightforward. You take a hash, you pass it, get onto another computer. Versus overpass the hash, you pass the hash and you also pass the ticket. It's a combination. And the real main difference between when you're going to use one over the other is dependent on what the authentication method is for the Active Directory. Is it using strictly NTLM or is it using Kerberos tickets? That will determine what method you're using. So, putting it all together, overpass the hash has 4 main sections. First, grabbing credentials from the local host. Second, passing the hash on the local device to create an illegitimate local logon. Third, creating a remote service call to the destination host, loading Kerberos tickets into memory. And then fourth, creating a pass the ticket event using the impersonated credentials onto the new device. Alright, so there are 2 ways you can spawn remote shells as other users. The first is a legitimate way, using run as command and just inputting their password. The second way is if you only know the hash of the user, and it is the illegitimate way. So as you can see, we're still on the Windows 10 device, and right now we are under our malicious, let's say our pen tester account, test admin, right? We'll start by spawning Mimikatz, and I'll save you all some time by just dumping logon passwords for the affected users. This is effectively the same thing that we did last episode with credential dumping. It's just a little bit louder, but it is a lot faster. Now, remember in this scenario, we're pretending that an IT admin, in this case, lateral user, has logged onto the device somewhat recently. Let's say maybe the user called in and said, "Help, I've downloaded 15 copies of Internet Explorer. Everything's running so slow. What do we do?" Who knows, right? And now that we've performed, I should say, our first step, we'll go on to our second step of actually passing the hash of our targeted user. And for now, we will just spawn a PowerShell window loading these users' NTLM credentials into memory. And what's interesting is we're still on our Windows 10 device, and we're still under our pen test account for now, but we have the user's credentials loaded into memory. And so now we move on to step 3 by making a remote service call to our targeted host that we actually care about. And what's interesting is if we list our Kerberos tickets, they're all for the user that we're currently impersonating. Now, usually this is a bit of an issue, but it's not make or break, right? However, some of the common sysinternals tools, like psexec for this example, allow us to spawn a remote shell using the currently loaded Kerberos tickets, because it's accepting under best practice or best faith, hey, I assume when you're trying to spawn a remote shell, you already have tickets loaded in for a user that you actually are. It just assumes that based on good faith. In this case, it's really just trusting that we're not being malicious, right? There we go. And if we see who we are now we have a shell as our lateral user, and we are officially on our domain controller. Now that you've seen how to spawn remote shells in an illegitimate manner using Overpass the Hash, let me show you how to spawn it in a legitimate manner using the native run as command using our legitimate account, Vagrant. In this case, we're going to be putting in almost the exact same command. We're still running psexec, we're still spawning it on our domain controller, still with a command prompt, but this time we're using run as, and we're telling it what user context we want to spawn under as. Now, if it's a legitimate account, it's going to ask us for the password of this user. And now that we've done that, we can see that we have spawned a shell on our domain controller as this lateral user, just like that. Now remember, Overpass the Hash is a 4-step multi-stage attack. We're not particularly going to care about credential dumping because we already made a detection for that in the last video, and we're going to ignore remote service calls because if we alerted every time something connected to an SMB share, we would never hear the end of it. We can, however, create detections separately for both the pass the hash and the pass the ticket events. What's more is we can actually join these two detections into one detection that will fire only when these two are detected within a short time frame. Now remember, our Vagrant account is the legitimate admin who is logging in using the run as command for our lateral user. The test admin account is the illegitimate or pen testing account used to log into the lateral user as well. Now, we could cheat and just say, hey, give me events with test admin. And that would bring it down to 3, which is a little bit lower than 2,126, just by a bit. But we can do something better. We can focus specifically on these two event codes, which in Windows are for descriptions of successful logons and privileged logons, or you can think of them as administrative logons, just to make sure we capture everything. And to define the differences between the pass the hash and the pass the ticket detection, we're going to be focusing specifically on logon types. In here, we even see 3 different login types. We have login type 2, 3, and 9. Now, login type 2 isn't really a point of concern for us. It's just saying, hey, a user logged in on the local keyboard and screen. This is me actually logging into the device. We don't really care about this. Login type 3, however, is overlapping with any login events that are over the network. Think of remote desktop. Think of our pass the ticket would also count as login type 3. For now, however, we're going to focus on our pass the hash detection, specifically using login type 9. Login type 9 covers impersonations, where one user spawns a service or shell as another user. In our case, we did that using pass the hash, spawning that PowerShell window on our Windows 10 device. And if we modify this, we can just click right here, we can see that we do indeed have one positive hit. We have our test admin creating an impersonation ticket, login type 9, for our lateral user. And we can narrow this down even further. We can say, hey, just as a logic check, let's say, hey, give me events where the account name is not the same as the network account name. So anytime when one account, in this case test admin, creates a ticket or some kind of service call for a different account, in this case lateral user. What's more, we can actually make this even more foolproof by saying, hey, give me these events where it's not a service account doing it and it's not an anonymous logon. We want to see only when legitimate accounts, or I should say real accounts, not necessarily legitimate, right, are creating another shell or service in another account's name. And so far, this should be able to catch our pass the hash events on the local device. Now, our pass the hash detection is set and good to go. The issue is, now we have to try and create a detection for pass the ticket, which unfortunately has a lot of overlap with legitimate logins. Specifically, we're going to be using login type 3 instead of login type 9 because login type 3 includes all network logons. These are any remote desktop logons, any PS exec logins. All of these fall under login type 3. And the issue is, even if we were to keep these same parameters, hey, no service accounts, no anonymous logins, we still have 6 events, which has both our true and our false positives in here. Even if we narrow it down to just logins to our domain controller that we know is the targeted device, we still have 5. Even narrowing it down to our lateral user only, we still have 5. And the problem with SIEM tools, especially when it comes to simple indexes like the Windows event log, is we have no way to determine true versus false positives for this login event. Sure, we can say some kind of impersonation level. This might assist a little bit, but there's still false positives even in there. And if anything, this should tell you, hey, you need both a SIEM and an EDR tool to help try and detect legitimate pass the ticket events. Now, what we can do is we can take this remote login detection, again, ignoring this section because that's unnecessary, and just say, hey, we have a fairly general remote login detection. Let's tie it to where it only fires when we have a correlated hit on our pass the hash detection. We're saying, hey, give us our pass the hash detection where we have impersonated logins using event codes, login type, not service account, and where the account name and login name are different. We can also append our search for these remote login events. And this gets us a little bit closer to what we're actually looking for, but we still have 7 events. These are still riddled with false positives and true positives. So how can we get it even closer? Well, in all honesty, we can, instead of appending this search, we can join it. Now, walking through what this does is we're taking our first detection, our pass the hash detection, again, using our login events and using only impersonation types, where it's not a service account, it's not an anonymous login, anonymous, where it's a different account spawning something under a different user, some kind of shell or service, and then renaming this targeted account as this target account variable. We're joining it to our second table of events, our remote login events, using our target account variable. We're saying, hey, join this only if we have remote login events under the same name. Again, if we have a pass the hash detection under Bobby Hill and the account name for the remote login within the specified time period, again, you can set it in Splunk. I wouldn't recommend all time. Just do maybe 4 hours, 24 hours. And the login event is tied to the same target account. Then populate this Splunk detection with events from the first table. Now, we see we only have an event from our test admin, our malicious pen testing account, impersonating our lateral user account. And the only way this table populates is if we have a correlated remote login on some device. Now, the issue with this detection is if you're a SOC analyst looking at this, one, it's going to take you a long time to figure out what in the world this is trying to detect, and two, it doesn't give you a targeted host, only the originating host. It also doesn't have any way to tell you true versus false positive because, again, remember, login type 9 also has overlap with the net-only switch. We're not getting a command line ingested with Windows login events. However, this is why you should have both SIEM and EDR tools, and if you only have SIEM tools, this should be roughly 80% good enough to tell you only when you have pass the hash events correlated with pass the ticket events. So, this detection will only fire our first table and show us events from here. That is a terrible eyeball, but bear with me, it's got some eyelashes. And it will only populate events if we also have remote login events, which we'll have to do for our pass the ticket events. As always, I hope you learned something, and if you have any questions, please feel free to reach out.